if you didn't like the last session or you really didn't like the presenter, I got bad news for you because I'm not going anywhere quite yet. We're changing topics only slightly, talk a little bit about operationalizing Snowpark Python. Really sort of the motivation or why my team and I started thinking about this concept came from understanding the different backgrounds that users who we were bringing Snowpark Python to over the last couple of years, where they were coming from. And in particular, I like to think of it as sort of 3 different directions from which people come. You have Snowflake SQL power users who understand store procedures and virtual warehouse compute and UDTFs from a SQL context, right? And they're really learning about just how Python and support for Python opens up new functionality for them, right? Doing things that you can't easily do in SQL through this, robust support for open source libraries and packages and functionality in Python. It's just a whole new world of what they can do. But the compute concepts for that Snowpark is really built on are familiar to them, right? Step 2, you have Spark users who understand distributed compute. They understand dataframe APIs in a sort of non-pandas context. They understand UDTFs in particular for custom functionality on data frames. And they're really just adjusting to the subtle differences in how the execution between Spark and Snowpark works. But from a, again, conceptual point of view, they're very familiar with kind of just like what their options are, right? If I need to do a certain bit of functionality on some data in a table in a Snowpark data frame, they can easily sort of map to, oh yeah, there's data frame calls for this, or I know how I would do this as a simple UDF or a user-defined table function or something like that. And then you have the third user, who is the Python user. They have a lot of knowledge about what they can do in Python, whether it's data science, data engineering, whatever it may be. But they've always worked in the context of sort of like single node compute, right? Locally, VMs, whatever it might be, right? But they're sort of just like working in a local Python context. They're building applications, but they've never had to really think about like distribution and scale of that compute as part of it. So I think really the goal for this session is really to help that sort of person. Oh, I'm Caleb again, by the way, if you weren't here before. But help that sort of user get a sense of how should I think about functional code as when to use data frame concepts, when to use user-defined functions, when to use user-defined table functions, what to package as a stored procedure, how do all these things tie together in the context of an actual task that I'm trying to accomplish, right? So we want to walk through kind of what that mental model looks like, an example workflow, and how I sort of would help a customer guide that customer into, here's how I would sort of design this. And then we'll go through my 10 commandments for performance with Snowpark Python. I'm going to be running a 45-minute session deep dive along this same topic tomorrow afternoon. And then this exact 20-minute session I'll be doing again Thursday morning. So if you'd like some more detail, please come tomorrow. It's in one of the rooms in this building. So a little bit about Snowpark Python, specifically when we're talking Snowpark Python. Now that there's Snowpark container services, it's important to distinguish Snowpark Python from other Snowpark stuff. But we're really talking about 2 components. Client-side APIs, which are those data frame constructs that allow you to use familiar data frame style syntax to push down data transformation, data manipulation, data queries to Snowflake compute from a native Python runtime. And then there's the server-side component, which I think that third user, this is the most unfamiliar thing that they're going to be encountering, which is user-defined functions and stored procedures and user-defined table functions that execute in Snowflake compute resources, custom language-specific functionality in a distributed and parallel fashion. If all you've ever done is written Python code in a single node compute environment, your career, that's fine. There's a lot of people in that boat, but that's all this very unfamiliar sort of content then at that point, right? Like we're talking about pushing functions and parallelizing them and how that all works, right? So that's the piece that we're really going to focus on. But it is important to remember that there are these sort of 2 distinct but related concepts with all of the different languages that we support through the Snowpark APIs and server-side runtimes. There's really, the top row of this kind of picture here really covers the 3 main concepts to be aware of. You have the API, which is the data frame kind of syntax for manipulating data with Snowpark, as well as the helper functions to deal with the other stuff. You have user-defined functions, which are data comes in, I do some processing to that row of data, output comes out, one-to-one style operations, with the exception of user-defined table functions, which we will get to in more detail. And then you have stored procedures, which are really just the hosting and execution of language-specific code, Python in this case, on Snowflake compute. Think about this as just running the script, right? If you were to kick off a script to run on a VM somewhere else already today, you just kind of like Python run that script, it runs start to finish, and it's done. The stored procedures then often utilize these other bits, the dataframe API and user-defined functions. So your stored procedures, your mechanism for really automating or executing sort of your functional logic of your code. Within that logic, you are then referencing the dataframe API and calling UDTs that actually do the data processing, with some exceptions. So I like to sort of work through this mental model. If you're doing transformation of data, you should be using the client API. And you could be using that client API from outside of Snowflake or in a stored procedure in Snowflake. It doesn't really matter, because the dataframe API, that client API, is going to push down the transformation work to where the data resides. It's going to execute on Snowflake virtual warehouse compute resources. The data is not going to leave the environment, and you're going to get the scalability and performance that you're expecting. If you're doing some sort of custom calculation, I have this row of data, potentially several values in a row of data. I want to do some custom thing to that and produce some new output column as a result. That's where your UDTFs come in, user-defined functions. Again, specifically user-defined functions are one-to-one style calculation. User-defined table functions give you stateful partition-based processing of the data that are a little bit more flexible, but as a result, a little bit more confusing if you've not worked with them before. When it comes to automation then of those resources, that's where stored procedures come into play. I need to run this script in Snowflake, process some data as part of this business logic that's contained in it. That logical flow, think about your stored procedure as like your main function in a Python script, right? This is just the thing that actually runs. And then within that, you might farm out work to other compute resources through the usage of dataframe API, user-defined functions, so on and so forth. Again, with some exceptions, predominantly the exceptions revolving around machine learning kind of stuff, but we won't really dig into that in this session. So if we actually take a look at what this kind of is in practice, on the right-hand side, you got everything that's inside of Snowflake. And on the left-hand side, you've got stuff that might be running outside of Snowflake. So if you're running some sort of external Python kernel in a VM, a notebook, wherever it might be, you've got a script or a notebook or whatever that contains, again, that functional logic. Within that script, you might use the client API to push down commands and transformation to Snowflake. Now you might, Snowflake selfishly, we don't want you to do this unless you have to. You might two pandas or collect that data out of Snowflake into that external client. But you also might create and manage database objects through the registration and management of stored procedures and UDTFs as well. When we talk about operationalizing a script like this that traditionally you might run outside of Snowflake, what we're really talking about is packaging up that script itself as a stored procedure. So the actual script runs inside of Snowflake as well in a Python runtime on Snowflake Virtual Warehouse compute resources. Within that script, again, you might be using the dataframe API, you might be running SQL statements, you might be calling UDTFs or whatever it might be, which then parallelizes execution across additional compute resources or leverages the native Snowflake SQL execution as well. Some of these bits will run in pure Python and some of them will run in SQL. Importantly, with user-defined functions, as we get into those execute as actual Python code. What Snowflake does for you is manages basically the parallelization and distribution of data to independent worker threads that are doing this across many, many compute nodes within a virtual warehouse compute cluster, essentially. So this is the mental model to work with, right? Stored procedures give us the means of automating, scripting, managing just sort of the business logic or the flow of whatever task we're trying to do. As you saw in the last session, we now have like task and DAG APIs that manage the actual scheduling and traceability of the execution of those concepts, but the actual like code that runs is in the stored procedure. You have the UDTFs for custom calculations, and you have the dataframe API for standard kind of tabular data transformation as well. So let's look at each of those in a little bit more detail. With data frames, these are familiar to, I think, all three of those user personas I described at the beginning. SQL user knows tables, we're good there. Spark user knows data frames and RDDs. Similar concept, a little bit different in terms of how it actually works on the back end, of course, in that we're not doing full like in-memory transform of the actual data. It doesn't reside on the worker nodes necessarily, but the concept is familiar. And even the pure Python user, every Python person knows pandas, right? So you're at least familiar with sort of this data frame sort of construct. But it's really just tables with rows and columns, right? Typically, you also then have these sort of helper functions that let you work with the data structure that, to create, save, write, all those kinds of options. And then you have queries and so on and so forth. Select style statements, functions and things you call against the corresponding columns and rows of that data to create new structures and all that kind of stuff. That's all data frames really are. Again, we've got a lot of different kind of frameworks for data frames out there. Pandas, Spark data frames, Dask, and now Snowpark. We've got the Python stored procedures, which are, again, effectively these Python scripts that the Python itself executes within Snowflake compute resources. Something to keep in mind with stored procedures is that because it's just the execution of a script, the actual stored procedure, the Python kernel that runs the stored procedure runs in a single node, non-distributed fashion. That's why it's extremely important to leverage the dataframe API, SQL, and UDFs, or UDTFs, within the actual the execution of that stored procedure to ensure you're getting kind of maximal parallelization and distribution of the work associated with transforming the data. If the code, the Python code you're writing is doing heavy work, it probably shouldn't be a stored procedure. Again, with the exception of some of those machine learning centric, kind of memory intensive, like very in-memory sort of operations, which is why we created Snowpark optimized warehouses to accommodate that specific use case. But anything that's doing heavy lifting really should be implemented as either dataframe APIs or some version of as a user-defined function. Because ultimately what happens with the stored procedure is if I bring the data into the stored procedure through a collect or a two pandas or something like that, I'm now working in the confines of that single Python kernel's memory footprint. Right? I don't have access to this large network of distributed compute nodes in my virtual warehouse to farm out all the transformation. If I'm invoking UDFs and dataframe and SQL calls within my stored procedure, I am leveraging that full kind of distributed network of compute resources. So Sprocs are really just that mechanism for automating and executing kind of the logic of your workload, but not necessarily doing the processing in that Python environment itself. Typically, what's funny is that most customers, when they first got started with Snowpark 18 months ago or whatever, they had some Python script that was running somewhere else. They just dropped that Python script into Snowpark as a store procedure, and they were like, hey, it ran. It didn't really run any faster than when I was running it elsewhere, but it ran. And it's like, well, yeah, because all you were doing is exactly what you were doing before inside of Snowflake now. So what we instead have to think about is how do we re-architect or refactor code or just kind of reframe the workload, the thing you're trying to actually accomplish in terms of these other concepts that give you fully parallelized distribution and execution. Things like our user-defined functions, which again are these one-to-one style custom transformations that basically parallelize execution of actual Python code. So whether you're using pure Python standard library or third-party open source packages through the Anaconda partnership or whatever, within this user-defined function, you're really defining rows of data in, calculation, output comes out, right? Snowflake then handles making that all happen in a distributed and parallelized fashion for you. What's I think really nice for that third persona Python focused user is they don't really need to understand how that happens so much, just that it in fact does, and so what kind of operations map into this particular model specifically. There are some kind of performance concepts with this, like caching specific artifacts. So like one of the most common examples we see for Snowpark Python UDFs are natural language processing pipelines, where you're doing like tokenization, named entity recognition, and things like that against raw text data or something. In those cases, those like underlying artifacts that you need to do that sort of work, you can use things like Python native cache tools to basically improve performance of runtime of those by minimizing the reads from disk of the actual artifact in memory into Python. So we will, again, doing this session in a lot more detail tomorrow, where we can really dive into what that means and how it all works. But it's something to keep in mind. If you have artifacts of some kind that you need in your Python code, caching the loading of those artifacts is going to infinitely improve your performance of these user-defined functions. The second piece is to always vectorize if you can. Vectorized UDFs really are the same thing, one-to-one functions that take advantage of Python's own internal vectorized optimizations. So a vanilla UDF basically randomly batches out the data to the worker nodes. Maybe we got a diagram. There we go. So if you call a regular Python vanilla UDF, what we're basically doing is spinning up independent parallel Python processes across all the various worker nodes in the warehouse in the secure Python sandbox. And then we just route the data to those things. Now in a vanilla UDF, as we route that data, we're basically like looping through the rows of data and running the UDF and returning the result. If you've like built software, you think, that doesn't sound so great. Lots of times different libraries are vectorized. Wouldn't that be better if I could take advantage of that? That's exactly what vectorized do in terms of modifying this execution model. You still get parallel independent Python processes. You still get Snowflake's distribution and routing of the data for you. But rather than iterating through rows of data, we pass native vectorized objects as input so that you can call then the optimized Python vectorized operation for that function against that input and get basically like batched execution. And think about it as like micro-batched execution, really, as opposed to kind of row by row sort of execution. But similarly, it's the same sort of model of parallelized Python processes operating in the sandbox across all the compute nodes in the virtual warehouse and churning through the data against which you're running this query. The larger the warehouse, the more nodes, the more processes, the faster it gets through the data. And then, of course, you know about how scaling up and scaling down warehouses changes cost and things like that with Snowflake. We just talked about Python UDF. Again, this basically lets you leverage Python's own internal optimizations for operating on vector objects instead of individual rows. Same process. The difference is we do batching for you along the way when it makes sense. UDTFs. UDTFs are so cool. And if you've not worked with SQL UDTFs, they're so confusing, man. Like, it never ceases to amaze me how confusing and complex these things come across as, but you can do so much cool stuff with UDTFs. UDTFs, really think about them like MapReduce, where you have logical data partitions of some kind defined by like a field in the data. So maybe you've got a bunch of historical you had like daily sales for all your different stores. And you have this store ID field where for one store ID, you don't really care about the other store's sales. You just care about that store. So it's like a logical way to just break up the data. This is not the same as how Snowflake partitions the data in storage necessarily. It might be, but it might not be. But you have this logical partition over which you need to do some kind of stateful processing. So UDFs, right? One-to-one and stateless. I don't know anything about the previous rows when I process a new row in a UDF. But in certain cases, like a UDTF, I might, right? I might need to know about all the previous rows, or maybe I only need to know about the lowest previous day sale. Think about it if you were trying to figure out on what date did each store have their lowest sale over the previous year, right? Now, for the SQL wizards out there, you're probably like, why on earth would you write a Python UDTF to do that? I can do that with SQL. Good for you. The extent of my SQL is basically select star from table, so that doesn't get you so far when trying to do stuff like this. But if I had instead all the records for that particular store for that year, I could just go through and say, is this worse than the previous low that I found? If not, cool, move on to the next one. If it is, oh, update. Hey, this is actually the new worst one. And at the end, I just want to return that one result. So we have a many-to-one style operation. That's what UDTFs enable, but they allow you to be more flexible. You can go one-to-many, many-to-many, many-to-one, one-to-one, basically anything that's stateful. And similar to the UDTFs, each logical data partition executes in a parallel and independent process on the worker threads across the virtual warehouse compute resource. So store 1 and store n are processing in parallel for you automatically. You just define how functionally you need to go through those records and operate on them, and that's really all there is to it. Again, I won't go into the full detail of like when you're writing the code, how does it all work. We'll talk about that in more detail at the session tomorrow. But that's how to think about UDTFs. It's like MapReduce-y kind of stuff that you really need to do, maintain some sort of state in order to do meaningful processing. So to motivate this example in the remaining 11 seconds that I have, we'll walk through just very quickly how I would think about this in a production workflow. And that is like something like customer sentiment. I've got raw transcripts from call center data maybe. It's already been, let's assume it's already been processed to text. We talk about unstructured data processing later, but assume we got text, raw transcripts. I need to clean those up and reformat them maybe. Maybe I need to segment, tokenize those things. I need to then run some sort of sentiment identification or classification against them. And then maybe I want to summarize that sentiment by demographic. Today, if you're not using Snowpark and that data's in Snowflake, cool, you're pulling data out of Snowflake, you process it, you write it back, you pull it out, you process it, you write it back. Bad deal, not a good time. Instead, Snowpark lets you bring this whole sort of workflow internally into Snowflake. And the way to think about this is, through the loading of the raw transcripts directly into the table, you can of course use the dataframe API to extract the records, insert them into table structures. Doing things like cleaning and reformatting, regex style parsing maybe of the underlying text then is very easily accomplished through either native SQL or the dataframe API, and you get to run this at tremendous scale across the virtual warehouse compute resources. Now, I need to go through all of my transcripts, and I need to run a particular sentiment identification model against them to determine which ones are positive and which ones are negative. I can do that easily with Python open source packages. There's a lot of good pre-built models to do exactly that. I just bundle that model up as a vectorized UDF, and then I call in a SQL call or a data frame context or whatever, call that UDF against those cleaned up transcripts, and then I have a UDTF now where I can say, okay, for this particular region, I now want to go produce some sort of summarization about the custom summarization or aggregation about that particular demographic with regards to sentiment or location or any other sort of like logical categorical variable in the data. Those are the functional bits that actually process the data. Now I take a stored procedure, and you might have just a single stored procedure that runs this top to bottom, or you might have several, who knows, but you have one or several stored procedures that say, cool, go run this UDF against this data. And that stored procedure executes in Snowflake as well, but farms out the actual bulk computation. Now, if you want to get real fancy, you can use the new task and DAG APIs to actually automate this to happen on a regular interval. Each of those stored procedures becomes a task. You now have a DAG that runs these dependent tasks in order. But from a Snowpark Python point of view, that's the key distinction in terms of the data frame and UDF constructs that are doing the heavy lifting, and the stored procedures that are just invoking them and managing the logical kind of business flow of your particular workflow. I'm out of time, so I'll stop here, and I will say if you want to get the 10 commandments for effective performance using Snowpark Python, you're going to have to come tomorrow to the more detailed version of this session. Thank you guys for your time, and I hope you enjoy the rest of the week here at Summit.